Okay, here we go. Chapter 7, the second of 4 videos on graphing polynomial functions. You kind of get the idea that this is an important topic, I hope. Okay, here we go. I'm going to review what we did in the last video, and that is we talked about if we have a cubic polynomial such as this, and it is factored, that we can easily graph this polynomial by changing the factors to x-intercepts. And so we realize that if these are the factors, then the x-intercepts that go along with those factors are -3, 1, and -2. And the degree of this polynomial equals 3. And because a is greater than 0, we know that as we go off the page to the right, we're going to increase without bound. And so we can see that the polynomial will look something like this graphed. Okay, that was old stuff. Now we're going to move to new stuff. So the question we're going to ask today is what happens if for this polynomial one of these 3 factors were squared or perhaps even cubed? What would that do to change the shape of the graph? So what we're going to do is what we've done a number of times, and that is go back to the chapter on quadratics and recall when we graphed the quadratic function p of x equals x plus 2 squared, what that graph looked like. And so just a real quick, to make sure that you believe me that this is a quadratic function, this is what it started out with. We factored and got that, right? We know that -2 represents the only x-intercept, but because it's a parabola, it still has to have the shape of the parabola. And so what we found when we graphed this was we got a parabola that hit the graph at the x-intercept of -2, bounced off, and continued above the graph. All right, using that same idea, let's go ahead and look at this polynomial. What about if we have x plus 3 is going to be squared, and then let's go ahead and add a factor of x minus 1. All right, not add a factor, multiply by a factor. So what would the graph of this look like? Well, the first thing we do, just like before, is we find the x-intercepts, and this time there are only 2, even though it is a cubic polynomial. Okay, so we know that here we have to bounce off to the axis, right? And because a is greater than 0, we know that as we go off the page to the right, after we hit this x-intercept of 1, we need to be increasing. And so the shape of the graph will look like this. All right? And in the beginning it seems a little unnatural. You might graph it the wrong way. You might have the bump coming up this way. But if you do, then you'll see that the shape could not have an a that's greater than 0. All right, let's go ahead and look at a quartic polynomial. So let's look at one that starts out the same, x plus 3 squared, but let's also make that factor of x minus 1 squared and talk about how that changes the shape. Now, I still have x-intercepts at -3 and 1, and because the factors are squared, I know we're going to bump, and so I'm thinking either bump this way, bump that way. I know a is greater than 0. And so as I go off to the left and off to the right, I must increase without bound, 4th power even polynomial. And so the shape of this turns out to be like that. Okay, hopefully that makes sense. One more example, and then we'll be done, and you can practice this in class tomorrow, is what about if I have, for instance, the polynomial p of x equals x minus 3 cubed. If a square next to a factor creates this effect of bumping off the axis, what does taking a factor to the 3rd power have? And what it does is it makes an S-shaped curve. So instead of on a typical going right through an intercept, right, what we're going to see instead, 1, 2, 3, we have one x-intercept at 3, is that it's going to come in like this and flatten out and then do this. So instead of shooting right through it when the factor is to the 1st power, when it's to the 3rd power, it has the effect of flattening out there. And we'll do some practice using Desmos tomorrow to explore some of these about why it is, but what you need to know is that if you see a polynomial, and so let's go ahead and do one example like that, if you have x minus 1 times x plus 2 to the third power, right? Okay, so this is our polynomial, and it is a quartic, fourth degree, right? We have an x-intercept at 1, an x-intercept at 1, and 2, we have a triple factor of x plus 2, so that means at negative 2 I've got to have an s. Right? And so again, because it is fourth degree and a is greater than 0, I know this is going to come like this. And so what I'm going to do is I'm going to come down here, flatten out at 2, and then do that. Okay, so it looks a little bit different than, say, if it was just x minus 1 x plus 2, right? Then we would just have a parabola. So I hope you can see the distinction between these two. It's a slight one, but it will make a difference when you graph it. Okay, last example I want to do is what happens if the polynomial I'm supposed to graph is not in factored form. So let's go ahead and look at x to the fourth plus 4x cubed plus 3x squared. And your job is to graph this. Okay, so the only way, and it's without a calculator, the only way to do this would be to turn this into factored form. All right, so we need two types of factoring here. The first factoring is the greatest common factor. We can see that each of the three terms has an x squared in it. And so that's step one, but we're not done yet because we can then factor this trinomial as x plus 3 and x plus 1. All right, and so then we can see that this is not a hard polynomial to graph once that it is factored. We have a double root at 0. We have roots at negative 3 and negative 1. All right, again, because the degree is 4, which is an even degree, we know that and a is greater than 0. We know that at both ends we are going off the page, increasing without bound. So now we just have to figure out how to get this double root here. Boy, that's not very good. I should have been more like that. All right, so double root at 0 goes through negative 1, goes through negative 3, and the end behavior checks. Okay, hopefully you got all of that. You'll have plenty of time to practice it in class tomorrow. See you in class.